Hi, everyone. Welcome and thank you for joining today's webinar, Freight Forward, How Cities and States are Rethinking Freight Management with Transportation Intelligence. We have three subject matter experts presenting today. Ahmed Durat, Chief Product Officer here at INRIX. We have Greg Johnson joining us. He's the Assistant to the Director of University of Maryland CAT Laboratory. And we have Jacob Sherman, Mobility Innovation Section Manager from the Portland Bureau of Transportation. Before we get started, I'd like to quickly review a few housekeeping items. Everyone is muted and will be throughout the webinar. If you have any questions during the webinar, please submit them through the GoToWebinar questions window. We'll leave time at the end for questions. This webinar is being recorded and you'll receive an email within 48 hours with a link to the recording. The recording will also be published in the INRIX resource library on our website. And without further ado, I would like to turn the webinar over to Ahmed.
Thanks, Janae. Hello and welcome to everybody. Good morning. I think we have people from all over the world today. So good morning, good afternoon, good evening, and maybe even some people good night. We're really happy to have you guys join us and talk about some freight data at INRIX. As we kind of get started here, we actually just want to take a little pulse of who we have in the room today so we can make sure that the discussion is catered to folks here. So you're going to see a poll pop up on your screen in a second. So everyone, please answer the question here. We just want to see what from a professional perspective, what are the majority of folks in the room? Right. Well, oh, we got engineers and planners, as is typical, battling to see which one's gonna be planners. Planners winning out here, so that's exciting. All right. The next question we got is what type of agency are you representing today? What type of organization are you representing? So, all right. Similar to planner versus engineer, which was, the majority of folks, we got city, county, MPO, and transit agency versus state. Again, the typical battle we see here in the public sector. So it looks like we got 45% of people in the city, county, somewhere around 40%. Keeps jumping up and down, and then state about 30%, consultant 6%, software fleet company at 9%, and other at 9%. All right, awesome. Last question before we really jump into the meat here. Where are you joining from today? We just want to get a geographical sense of where people are in the world as well. All right, pretty much everybody here is from the US or Canada. Awesome. So thanks everyone for answering those questions. All right. So I'm going to talk a little bit about INRIX and what we do before I jump into our guests here today. So for folks that don't know, INRIX has been in business of transportation intelligence for about 20 years. And what we do is we take in millions of probe data sets and billions actually of data probes from tons of different sources. And we build analytics out of it. And I think, one of the areas that we're most proud of and where we have actually, our most unique offering is really in the fleet and the freight world. But a lot of times when we talk to our customers, there's a lot of confusion about INRIX data and data from our competitors and other folks. So I like to set this context up at the very beginning of any discussion that we have. About using, probe-based data, using data from vehicles for transportation analytics. And so I like to talk about this in 4 different ways: observations, models, normalization, and insights. So observations are things that we directly observe as a company. So we receive GPS points from companies, and then we turned them into an observation. We didn't do anything other than maybe some processing, some map matching, things of that sort to create an observation. It was a 1-for-1 representation of the data that we received at INRIX. So this includes stuff like our trips products, and a few of our other products in the freight world. We have NPM RDS for folks. Again, most folks are in the U.S. might understand and know that product. Then we have modeled products, which is a lot of what we do here is scaling up and modeling what we actually think happened on the road. So we use artificial intelligence to scale up the GPS observations. The third piece is normalization. Normalization is anything that we have to do geographically or in time space to make sure that our models, we've been in business over 20 years. Our models, they change over time. So sometimes we have to normalize to say, hey, last year's data and this year's data might look slightly differently, but it's within the margin of error of the model. Therefore, we need to normalize it so people understand year over year how to make comparisons. And then insights are targeted analytics that we provide. So we have our generative AI solutions that we provide to our customers, which really give you feedback that interprets the situation that's happening and gives you information. And so that's just context I like to set at the top as people are evaluating and as we talk about some of the use cases here during this session. Making sure that we understand the differences between these things. So like a big one that you see in the world right now is a lot of people talk about volumes and trips as the same thing, but they're not the same thing. A trip is an observed product, a volume is a scaled product. And so I know a lot of our competitors almost talk about those things interchangeably, and they're very different from each other. I'm going to talk again, one very quick discussion about some of our freight solutions. So you're going to hear about two versions of our freight solutions today. One of them is going to be very focused on kind of like the planners and the operators in the road that are focused on the trip patterns themselves of the actual observed trips. They're trying to understand what's happening in the world as far as freight movements from one place to another. And some of the key features at Inrix, and again, that's why I said our product is incredibly unique in the market. No one else offers what we offer when it comes to freight trips. We have about 20% penetration rate nationally across all roadway classes. So we have a significantly more penetration rate in the freight world than we actually even do in the passenger world. We have dozens of data sources, of freight-only data sources. Our sources, and this is where our product is incredibly unique. We offer both individual trips and aggregated trips. So our individual trips are snapped to OSM segments. So that's what you see on the screen here on the left. We snap them to OSM segments and we provide a path. Greg is going to talk about that in a lot of detail. We have different vehicle classifications at a pretty high level. These are not FHWA classifications, but just generalized vehicle classifications. And then we see some stats there about what our data is. The typical freight trip is about 60 miles long. It's about 70 minutes long. And then the ping frequency is about 25 seconds. So we get a data point every 25 seconds. And then the delivery process is something that's actually kind of unique here. Again, we typically deliver to most of our customers, again, from the planning sector. They only really want to see it once a month. But then oftentimes we have emerging events. We've worked with the state of Maryland on a bridge collapse there. We had, bridge collapses and major incidents and events that happen around the world where we actually provide latency that's 2 to 3 days, sometimes every week, where we present data with something that's an emerging trend that they need to keep track of on a much more frequent perspective. Then the last thing I'm going to talk about is what we do in urban freight management. So it's a little bit different because it's not just us providing data. In the instance of urban freight management, it's much more of an ecosystem and a process. So what we do is we take data from tons and tons of devices, e-cargo bikes, cameras out in the field, payment applications, cars, shared mobility, from parking garages, things of that sort. We deliver it to cities the same way that we deliver trips, where it's data that's analytics that we provide to the cities for them to make decisions. But then we also provide software for cities to then communicate back policies, and we send those policies over to a lot of the operators in the right of way that are doing freight and urban freight activities, and also just general vehicles and other types of vehicles. And so you're going to hear a lot about Jacob about that. And so with that, I will say we're having a technical issue just across the board in GoToMeeting right now, so you're not going to see anybody's face today as we talk. We're just going to be kind of disembodied voices. But I'm going to pass along. I'm going to pass this over to Greg, who's going to talk about some of the use cases that they work with at Cat Lab. So with that, Greg, feel free to take over.
Thank you, Ahmed. How do I sound?
You
Oh,
sound great. Just I think
okay,
the
good.
screen share just needs to go back to the presentation.
Here we are.
There we go.
All right, hello everybody. This is Greg Jordan. I work at the Cat Lab. I work closely with Michael Pack and Rick Ayers and other people there. The Cat Lab is really part of University of Maryland. We are not associated or a part or linked formally to INRIX. However, over the course of the last 15 years, INRIX has really developed the agency products and market. They've focused on it so much that we end up doing a lot of work with INRIX. So we actually do work closely with them. Um, Today we're going to talk about freight analysis using the Trip Pass product from INRIX, and also a program that we wrote at the Cat Lab. I used to hover helicopters and use them to trace trucks around. For example, Rhode Island wanted to do a statewide OD study, and on freight vehicles, it was actually a total revenue forecast. And at the time, the INRIX product was brand new, and I actually hovered a helicopter near Providence, Rhode Island, so that I got a kind of a subset of the state, and I could compare the INRIX results with the helicopter and got very close match. And is what satisfied the state that it was okay to use this source for a total revenue forecast. But essentially, what is this trip pass data product? It has millions of actual real world trips, and I won't repeat what Ahmed said, but uh, essentially, GPS pings are collected and snapped to roadway networks. And for cars, it can be cell phones, but usually the trucking fleets have their other telematics. Um, every trip has a time and location of where the trip started, where it ended, and the segments along the way. So you actually have a pathway between a start and an endpoint. Um, Generally, a data set includes the entirety of all trips for which the pathway intersected a base geography, like the state of Pennsylvania. If a trip is in INRIX's, if they've sampled the trip and they have it available, essentially they scrape out all of the trips that intersected the state of Pennsylvania, let's say, but you get the whole thing. So if the trip started in Ohio and went off to Vermont, if it touched the state of Pennsylvania, you'll see the whole trip, and you'll have the start time, the end time, and so on. So that's an important feature of what it is. I'm going to introduce this by way of applications and just kind of talk through things that somebody might want to do. Suppose you wanted to analyze freight movements in the vicinity of JFK Airport up on Long Island, and you developed these zones, and you wanted to know about the ship movement of trucks or freight to and from these zones. The first thing you'll do is basically set up a study area that you care about, one that includes all of your zones, and it may reach out a little bit further. But in this case, a study area is on the left. The tool takes that study area and takes those zones and puts them together. And essentially, this is how origins and destinations are going to be defined. It's like the deck plan of a ship. It's like a stadium plan. It's simply a map with names on it, so that when you sample trips that move around, you have a fixed way to understand where those trips came from and where they went to. For example, these red dots around the edges, those are roads that cross in and out of the study area. For some studies, you don't care that a trip came from the Bronx or came from Connecticut. What you care about is where it went in and out of your study area. So these are all OD gates, and those can be your O's and your D's can be the crossing points. But if you want to know it came from Connecticut, you can also choose that option as well. But anyway, so the setup is simply, how do you want to name your O's and D's, your origins and
Hey, Greg.
destinations? Hello?
Quick question. For the New Jersey truck cut through example, how long did it take to set up and run the analysis?
Well, how about generally speaking, analyses can take anywhere from a couple of minutes to a couple of hours to a couple of days, depending on how much digging into the data set. We are actually rebuilding the back end, and it's going to be about 10 times faster as soon as we get that completed. That particular study that I'll talk in a little bit, I think the queries were usually about 15 or 20 minutes, I think. Um, and at some point, if anybody wants an actual demo of the tool and how it works, I do a lot of demos, and I'm very happy to do that there. So once you've set it up, once you've got a map of where things come from and go to, you get to run scenarios, as many scenarios as you want to. And you basically put down polygons on the map. In this case, we could use the study area as a spatial filter and saying, find all trips that intersected that polygon and pull them out, and we're gonna map out and make an OD matrix of them. But we have these pass-through settings, and these pass-through settings give you a lot of control about which trips you want to pull out. If you're looking at automobiles arriving from 7 to 9 in the morning into a downtown area, you say, look, give me the trips that started outside my polygon and ended inside. In the evening, you want the reverse. But if you're only looking for trucks cutting through a neighborhood, you want trips that started outside the neighborhood and ended outside the neighborhood, and so on. So you have these choices. So if we go back to our study area here, we can run many scenarios with many combinations of spatial filters. For example, we can throw down a from polygon that has the two ways into the study area, and a to that gives me directionality. Trips approaching from the west. Let's just find those trips, and then we'll basically talk about when we want them and which ones. We want medium trucks, we want heavy trucks, we want cars. You set up where they went, when they went there, which ones went there, and then it reaches in and it finds all those trips. So here are the trips. This scenario, we found 6,939 trips that are in the data set, based on these settings that are over here. And once you have that map, you can kind of isolate and dig in information about it. Like, one particular route, you can come out and you can actually draw a screen line and figure out the percentages of trips that crossed, this road or that road. And if a bridge goes down, this is a nice time series tool where you can actually see where the shift went. And I'll show that a little bit later. And then you get information about each unique pathway. So in this case, of the 6,000 trips, 1,000 of them took this one. It was a 7-mile with the average travel time of 14 minutes. And then we had the 5th percentile and the 50th and the maximum. And so on. So there's information that you pull out that way. You also get to look at the trips in the form of an OD matrix. Nobody really can look at an OD matrix and make much sense of it, but your computer models need this input in this format. If you want to, remember that we surveyed these two coming in here. The two ways in are the Belt Parkway and Conduit Avenue. So they're the main ones right here. It's got 2,000 from there and 4,000 from there. That's where most of these came from. Why not take this table and stick it on a map? So that's what it looks like. Same numbers of the OD matrix, but there's the 4461 from Conduit Boulevard, and 2239 is the ones coming from the Southern State Parkway. So between those two, you can actually click on either one of them and it'll break it out. Those are just the internal numbers of the OD matrix. So that's one way. That's just introduction to the tool and talks about kind of how it works. Basically, once you find the trips, you find their origins and destinations and their routes, and then you have 3 reports: the matrix, the zone map, and the route map. So here's another example. Suppose, and this is the one that Janae asked earlier, there are reports that trucks heading to Manhattan are not staying on the New Jersey Turnpike extension into the Holland Tunnel, but instead are cutting through the local streets of Jersey City. How can we use the tool to kind of quantify and see whether that's happening and is it a significant number? So we draw a special, what I call a cookie cutter study area that encompasses all the different routes. If someone's going to cut through, I want everything inside my cookie cutter study area. And I call it cookie cutter because anything outside of it is going to get trimmed away, and we're going to get travel time statistics, not only for the main line, but also for any cut through traffic, and each route will have a travel time for. So once we have that cookie cutter study area, then we set up a spatial filter. We put a from that crosses the road coming in and a to. So we're looking for pathways that intersected both of these polygons in that order. And once we find them, we can look at them and see some information. So there's the route map. And notice we drew a screen line, and the screen line always adds to 100%. You can put it whatever you want to. Looks like 79% of the trips are taking the main line, and that leaves 21% that are cutting through. And if I want to know where they're cutting through, 19% of them are going here, 1% there, and 1% there, and so on. So we've confirmed that a fifth of the trucks, and these are medium trucks because the Holland Tunnel does not allow tractor trailers, a fifth of the trucks that are going to New York to Manhattan are cutting through the local streets. How about the travel time? Well, we got 50 of them following this particular route, and it took on average about 27 minutes. That's the median. Whereas the main, the 79% that stayed on, they took about 31 minutes. So we're actually documenting a 4-minute typical travel time improvement by cutting through the local streets. Third application, an emergency closure of Interstate 15 in Las Vegas. We drew a cookie cutter study area. The star is where the highway was closed. Southbound 15, it starts up at the north end and flows to the south, so it's closed there. So we drew a cookie cutter study area to encompass all of the cut through routes, and then we filter looking for it. This was just one incident for several hours, so we had 5 tractor trailers that followed this route, and it took 41 minutes and it was 10 miles. We had 3 that followed this route. And one of the other things you can do is you can click on a spot and you say, I only want to look at all the trips through that spot that I clicked. So if I click on the off ramp at West Flamingo Road, it's going to now show me only the trips that went through that spot. And I can see how they fanned out and where they went, of the ones that went through there. And so I can move that spot around and get various things. So how about route changes, the Key Bridge in Baltimore, mentioned earlier. The first one we'll talk about for general traffic, autos and trucks. How did they shift getting from the south side to the north side? And there are basically 5 ways to go. You can go around the Beltway to the west. You can cut through local streets. You can take the Fort McHenry Tunnel and the Harbor Tunnel, and then the Key Bridge. So beforehand, you had Key Bridge. Of all the traffic crossing this line, or actually moving from the pink area to the pink area, 30% of those vehicles took the Key Bridge. Where did they go when the bridge disappeared? And the answer is, well, you lost 30% there. You got 11% at the Harbor Tunnel and 17% at Fort McHenry. So that's basically the traffic converted, and we can see that most of them actually switched to Fort McHenry than they did to the Harbor Tunnel. And we can do it for the other direction as well. Here's another question. What about Sparrows Point? This is a shipping terminal that was outside the bridge, so it was actually not blocked. Unlike, when the bridge went down, it blocked all the terminals to the west or inside, but outside, this terminal could stay open. How did those trucks go to get to various points? So you say, okay, well, we had a from and a to polygon, and the to was this long. We want to know where did they go. If we wanted to choose just the ones that went to the Bay Bridge to get to the other side of the Chesapeake, beforehand, 96% of that traffic crossed at the bridge that disappeared. Afterwards, we got about a split where you can actually see the pathways they took to get from here to the two tunnels, and 55% took the Fort McHenry tunnel and 45% took the Harbor tunnel. So we've got a documentation. Likewise, how about trips to the west? And one of the interesting things is that you've got a big route, the Beltway around the outside of it. Um, Only 6% of the traffic went that extra distance. It's a longer distance. 93% took the Key Bridge when it was there. When the Key Bridge was gone, that 6% went up to 43%. We had an enormous amount of truck traffic going around the Beltway. So there's a documentation of the changes. Now I want to talk about truck parking. And one of the things these are all new things we're doing, but right here, right now, we're ready. States can actually already do some of these analyses with the tools that we have today. And let's just talk about not legality, but let's talk about safety. Are you parked where you're not going to be basically be adjacent to high-speed highway traffic? So we have defined it to mean safe is you've got more than just an off-ramp between you and the high-speed traffic. So we have safe. It can be legal or illegal, but it's away from the high-speed traffic. If you're parking along the off-ramp and you only have the off-ramp between you and the high speed, we're calling that unsafe. But it's not as bad as dangerous when you're literally on the shoulder and there's no separation between you and the traffic. And we're looking at ways that we could use the data to come up with it. So we actually drew these zones for trip analytics, and we basically have an upstream dangerous, upstream unsafe, your whole safe region, downstream unsafe, and downstream dangerous. Well, the idea is that if you've got a lot of parking, especially in the downstream dangerous, it means that drivers did not feel they had an alternative, and they ended up parking down there. Obviously, you don't want trucks will park in these other areas. We found a lot of people parking in the upstream unsafe because I think drivers perceive it as being relatively safe and they don't know what they're going to find downstream, and maybe that's why we have a lot there. But here is using the regular Maryland data set and looking at a period. We used October of 2024, and we used heavy trucks. These are just tractor trailers, and we're showing 86% of the trucks parked in the safe area, and the dangerous, we had a 1% number up there and a 3% number downstream. I actually did visits myself to this area to learn what was there, and I found a pretty good correlation between what we saw here. Now, we could rerun this. INRIX is actually working on a deliverable that I'll talk more about in a minute, whereby on places like freeway rest stops and maybe truck stops, they can deliver to us endpoints that are not scrambled as much. Generally, those endpoints are blurred, and I'll talk about that more in a moment, but a more precise unblurred endpoints, I reran this with a test data set, and I got very similar results. So if I go back and forth, this is the data set that's the normal delivery, and we've got 86% here and 6 and 1 to the north, and now we have 88%, 5 and 2%. So even though that first one was less precise, we're getting very similar answers with the more precise data. And when I say precision, here's the point. For privacy protection and the business interests of the trucks that provide the data, and this is so important, INRIX maps the endpoints to a 200-meter grid. So for trips that finished in the vicinity of this rest stop, we're showing 1448 inside the box, but we also have a lot around it. And some of these trips have been mapped out to there that might belong in here. So this is the blurring that is part of the privacy. What happens if we look at the more precise versions? And this is a truck stop on the right, and this is you still have them mapped it's like 20 meters, I think, or 10 meters. I forget what the size of these dots are, but we actually have more precise information. And so we took a close look at that and went around Maryland and found this concentration of stoppages on a freeway. There's a wide shoulder here, but there's still it's still unsafe area. So we're just looking at ways we can use the data, what we can find. Here's that same uh, uh, rest stop we were looking at before, and we have all these are heavy truck locations. And if I throw in the medium trucks in blue, we can actually see how medium trucks have parked around the perimeter where heavy trucks can't go. So, out here you can put medium trucks here, but you can't put heavy trucks. So we're kind of exploring the ways to do that. We are coming soon. INRIX has introduced the concept, and they have a new product called stopped trips, which sounds like an oxymoron, but essentially it's a trip that we're looking at the duration. It's a parking trip, a trip where we spend time parked. So the start of a parking trip is when a regular trip ends, and the end of the parked trip is when they leave. So there's a lot of information about arrival times, about durations, about how far they traveled coming in or how far they traveled when they left. All kinds of metrics there. We're working on these soon. This is the development phase. This is before we build it into the tool. We analyze it and discover what we can. But we have here's that same rest area that we talked about. Here is the duration of the parking events for certain dates or times. Uh, Day of week, what is the duration by day of week, and what about by hour of day? And then you can actually look at it. This is a more broad view of a consolidation of all of these rest stops in the state of Maryland. And then here's information about the trips that we can actually dig into under the hood if we need to look at it. So that's my presentation, and I'm here if there's any questions. And again, I'm happy to show people how to use the tool and train them on it. You just have to let me know.
Fantastic. Thanks, Greg. That was incredibly comprehensive and a great demonstration of all of the vast number of use cases that the Trip Analytics tool offers, and some of the work that we do with Cat Lab. I really appreciate it. We're going to now jump over to Jacob Sherman from the Portland Bureau of Transportation. And then we know that we got some questions in the questions box here. We are going to answer questions after Jacob's presentation. So we got them. We're going to run through those. Jacob, go ahead.
Great, thanks so much, Ahmed. Just confirming everyone can see the screen and hear me?
Yes, sir.
Wonderful. Well, thanks for the opportunity to come and talk about some of the work that we've been doing with INRIX and other partners. Again, my name is Jacob Sherman. I manage our mobility innovations team here at the Portland Bureau of Transportation. One of the projects that we've been working on for the past almost 2 years now is the United States Department of Transportation Strengthening Mobility and Revolutionizing Transportation, also known as SMART, grant project, where we've been using advanced technology and curb management policy to test a zero emission delivery zone in a part of our downtown. The real focus of this has been to understand how policy changes as well as advanced technologies can help us improve safety, public health, and potentially lower greenhouse gas emissions. Within our larger project, we had a 6-month demonstration project where we reprioritized 5 truck loading zones to be for permitted commercial zero emission vehicles only. At all of those sites, we also installed kind of advanced parking camera sensors, and then worked on a bunch of curb digitization efforts, which I'll talk about. We also enforced our regulations, and parking enforcement issued citations for vehicles that didn't comply with the zero emission commercial delivery rules. as I kind of mentioned, there's a lot of curb digitization efforts kind of in the background of this broader project. Kind of at its heart, our Smart Grant pilot project was testing kind of three key questions, kind of understanding kind of whether and how curb management changes can help advance some of the city's adopted climate policy goals. Also really wanted to kind of test out some digital right-of-way management technologies to kind of understand whether and how they could help us better manage the right-of-way. And then there's a number of public-private partnership kind of components, which we'll also get into. So both the technology as well as kind of the partnership questions we'll be talking about in the slides that follow. From a technology partnership perspective, our project really worked to kind of create an ecosystem around data sharing. Data sharing where private psychologistic operators could share data with INRIX and their software as a service platform in order to kind of spool up advanced analytics that the city could have access to in order to better understand how the street network was being used, as well as kind of the policy changes on the zero emission delivery zone were being kind of implemented. At the same time, we also worked with two different camera sensor companies, both Automotus as well as Clever City, to build out data integrations between them and INRIX using open source data standards like the Curb Data Specification, which is something stewarded by the Open Mobility Foundation, in order to share data between the sensor companies and INRIX, and again, get that information loaded in INRIX tools so we could understand how the curb was being used in near real time. All of this as well was using some of INRIX's curb analytics products, as well as some of the sensor data, in order to share information back out with private sector partners like Beeline, this psychologistics company operating in Portland, to let them know if the curb was being occupied, as well as some of the other curb rules. And I'll kind of dig into this in the next few slides. One of the key things that we did in working with Beeline, there again are a psychologistics company that's been operating in 15 years, doing all sorts of deliveries, and they came on as a key partner in this project. And kind of like Greg talked about from a large freight vehicle perspective, Beeline actually installed telematics devices on their cargo trikes in order to improve their own data systems, but also be able to share data in the ways that was just described on the previous slide. When we started the project, a lot of Beeline's processes were analog. You can see kind of a photo on the far right. There's a manifest of deliveries. You can see scheduling occurring on things like the whiteboard in the center. And on the far left is kind of a schematic of some of the data systems that Beeline had, but notably none of those data systems was kind of interconnected. And through the course of the project, in helping Beeline build out their digital tools and ecosystem, they managed to kind of more successfully connect some of their own systems, driving operational performance and efficiencies. And they also managed to build out systems where, kind of shown on the far right, they are actually able to use APIs to hit INRIX's data systems, pull up our curb rules in real time in order to kind of understand where some of the places to park the cargo bikes were located. And then later, as sensor integrations occurred, whether or not specific places like truck loading zones with sensors at them were occupied or unoccupied. The data integrations that I just kind of talked about also helped us develop some really helpful analytics. And this is a screenshot of one of INRIX's tools where we as city officials were able to see where Beeline's trips on their e-cargo bikes were ending. This is a heat map showing trip ends. The dark purple hexagon is Beeline's micro distribution center, so it's no surprise that a lot of trips in there. We're also able to kind of dial that in, get more closely, better understanding of where those areas are. As you can see kind of on the map on the left, and I'm not sure, yeah, my cursor is there. This is the area where we had our pilot zero emission delivery zone, and you can see well over 200 trips kind of ending in this area, as well as some of the adjacent areas during our pilot project. The map on the right is some of the route data. So just as Greg was talking about capturing route data from medium and large freight vehicles, this was also capturing route data from cargo, e-cargo trikes. And what's really interesting here is to be able to kind of compare and contrast the transportation system as it mostly is designed for automobiles as well as larger automobiles, for how e-cargo delivery company is using it. And so some of the images here, not all of them, or some of the routes here, but not all of them, actually really start to show the city's neighborhood greenway network and how this company is using that as kind of the backbone of their delivery system. This information is really helpful for us as local officials as we're thinking about how can we move goods out of big trucks and, ideally into smaller vehicles that use less fuel and are much safer. Another kind of component of the project, as we talked about, was digitizing all of our curb rules. So the city, when we started the project, had a limited inventory of our parking and curb rules. And working with INRIX, we worked to make that more robust. And then again, through data integrations with some of the parking sensor companies, we were also testing out how we could understand where truck loading zones were used and some of the analytics on their use, such as occupancy, such as dwell time. And you can see here in the lower right-hand corner an image captured from one of the sensors of an electric FedEx truck parked in one of our zero-emission delivery zones. Through the course of our pilot project, we ended up permitting over 65 different vehicles that were all accessing these truck loading zones, as well as other traditional truck loading zones kind of in the course of the project. So maybe just kind of wrapping up, some of the exciting things that we've done through this project really, I think, are at the kind of cutting edge of digital right-of-way management. We successfully tested some of these newer open source data standards and really were able to, through this project, kind of use things like the curb data specification as a common language so that cities, data aggregators, sensor companies, logistics companies, and others could effectively share information with one another so that we could all inform our own kind of decision and planning in an effective way. Some of the things that we did in this project were some of the first kind of known data integrations in this space. We also had a number of successful partnerships, and this is by no means comprehensive. But one of the things I think we're really interested in is showing how some of these two-way data integrations between Beeline and the city, where again, Beeline was able to access our curb rules in a very granular way. And we were also able to communicate back to Beeline if those curb rules were changing, or if some of our truck loading zones were occupied or unoccupied using INRIX's tools. Really goes to show how these approaches could scale to other use cases. Those could scale more broadly to freight applications like we're talking about on the webinar today, but could also be done to other things like robo-taxis, Uber and Lyft, food delivery, and probably much more. So it's been really exciting to kind of build out, test this kind of proof of concept in a little bit of a sandbox with a great partner like Beeline, recognizing how these tools and technologies could grow more broadly through a partnership or a regulatory approach. We're wrapping up our USDOT Smart Grant project. We're going to have a final report coming out later where we're going to talk both about the technology side of the project in more detail, as well as the kind of policy side. So feel free to stay tuned for that. And until then, if you're interested in learning more, you can always jump on our website. We also had an article about our project featured in the February issue of the ITE Journal, and happy to connect at NACDO if anyone's there. So thanks so much for the opportunity. I'll hand it back to you, Ahmed.
Thanks, Jacob. That was amazing. Thanks for your presentation, and we're obviously incredibly excited about the work that you guys are doing in Portland, and how cutting edge it is. It's something that there have been a lot of lessons learned on our end too. So we have about 14 minutes left here. We have a few questions already in the question box, but if folks have more questions, yes, please feel free, especially questions directed at the speakers as well. So I'm gonna start going through some of these, but yeah, folks, please feel free to add some more. So one of the questions that was asked in the chat here was about the Screenline process and how that works, and whether or not that was in the RITIS tool. So Greg, do you want to talk just very, very briefly about the simplicity of the screenlining process in the RITIS tool?
Sure, and it is in trip analytics. Once your filters have grabbed 1,000 trips or 500 trips or 50 trips, once you put them out on the map, when trips overlap each other, you can hover your mouse over any segment of the highway and it'll count how many trips crossed that spot. So the screen line gives you a way to draw wherever you want to, and you pick it by direction because it will count by 2 directions. So once you've drawn your screen line, it will then count how many of those trips were crossed by the screen line. It adds them up to 100%. And then you get the percentage split at each crossing. You can save the coordinates of the screen line, and then if you want a time lapse that says, okay, well, the crack was found in the bridge on Tuesday of last week, every week let's rerun the same screen line and see how the patterns shifted, or once the repair is made, how quickly did it get back to normal, or so on.
Great, thanks, Greg. Going to the next question here, somebody asked about the recording, just for folks that might be following online and maybe want to reference back to this to the presentation. I've dropped the link as a response to that question for everyone. So there's a link where we have all of our webinars. So I would encourage folks to go back to that link, and if there's a topic there that you're interested in, feel free to be able to access those videos.
Yes, you'll also receive an email with a link to this specific recording.
Awesome. Thank you, Janae. The accuracy of the data. So this was kind of we provided a pretty long answer here, but this was one of the things that Greg showed actually in the presentation there. I know this question came in just a little bit before it, but we'll dive a little bit deeper on that. So essentially, what we do is there's a few ways that we anonymize and aggregate from a privacy perspective some of our trips. So the 2 different ways we do it is we aggregate on the routes, and then we aggregate on the geographies. So the reason we do that is obviously most of the folks that we work with, especially in the public sector, they're interested in understanding what's happening on the roadway. So that's why we aggregate to the routes. So when you see our trip paths data, yes, we'll give you an individual trip, but it will show up as a path. It won't show up as the individual dots that INRIX receives. It'll just show the path, and it'll show when somebody entered and exited that path. The other element we do is on the geography, which is what Greg showed earlier. We take the GPS data and we aggregate it to a level to where we remove some of the GPS points or some of the decimal points on the end of it, the accuracy and the precision of it, to be able to just give people that 200-meter area of where the end of the trip was. Again, from a privacy perspective, we do that on purpose. Now, the other element that Greg showed is a partnership that we're working on with Cat Lab, and we have a couple of other kind of like suppliers that we work through that support visualization tools, right? So in the case of Trip Analytics, the visualization tool, what we do is we provide a much more granular GPS point of the end point of the trip, and it's very highly focused to be able to, again, still continue to protect privacy, because all we're giving is the point of the end of the trip. So we're still protecting the privacy, but so there's no other element of the trip itself. But then at the same time, you can better understand in those rest areas, in a in a specific location on the roadway, you can really, really, really pinpoint those locations where there might be some issues. And so that Greg showed that piece at the end there of his presentation of the parking dashboard that we're working on with Cat Lab, where Cat Lab is helping us to do some of that aggregation and present that information into a way that's usable for the agencies. Another question we had here, or not a question, it was a comment. Appreciate the comment, Brooke, about not using the words unsafe and dangerous. Very good reminder for folks on the call to be conscious of the wording that we use, especially in official reports. And then I actually had a question of somebody internally at INRIX pinged me, so I'm going to throw it into the mix here because it showed up on my slide, and Greg talked about it briefly as well, of a stopped trip, the concept of a stopped trip or a non-moving trip, and how that's defined. So part of what we do at INRIX in our trips data is typically most vendors, what they will do is that they will provide a trip start and a trip end that is based off of the engine start and the engine shut off. That's usually the trigger for the trip, right? When the trip started is when the engine turns on. When the trip stopped is when the engine stops, right? Now, in the freight world, that isn't necessarily what most people that are trying to analyze a trip are interested in, because a lot of people in the freight world don't actually turn their engines off when they're stopped, because a lot of times their engines are running their heaters, they're running a lot of auxiliary pieces of the setup that they have, so they don't actually turn the engine off. So we have this concept in our data set of a stopped or a non-moving trip, where we will end a trip if a vehicle hasn't moved more than 200 meters in more than 10 minutes. So 10 minutes, 200 meters is the trigger. And so a lot of those parking related use cases that Greg had showed there, a lot of cases we are considering also the non-moving trips within that. So, obviously somebody stops on the side of the road, they're there for 10 minutes, they haven't moved for 200 meters, they're on the on-ramp or they're on the off-ramp. It's pretty much the same situation as if they turned the vehicle off and they were there for 2 hours, right? At the end of the day, they're still parked in a place that probably as an agency, you don't really want them to be parking in from a safety perspective. So that's conceptually what that concept is. With that, I'm gonna just kind of make one more check of from the crowd here. If there's any other additional questions folks might have, feel free to drop them in the chat. And if not, maybe I'll just ask Greg and Jacob. I know I'm dropping this on you kind of quickly here, but just kind of like one parting thought from each of you, just as a kind of maybe either a summary or something for folks to take away from the presentation here. Maybe just a minute or two of a thought. Greg, you want to go first?
Sure. Thanks, Ahmed. I would just say that, and it's kind of a sad thing, but I used to fly helicopters. I did about 80 helicopter surveys, And I've had so much enjoyment building this tool and being able to do it from my desk and not worried about clouds and weather out there. Um, it's my idea of a good time to show people how to use this tool. So you won't bother me, do a web meeting and just one person. I do a lot of just single one-on-one or one on a group of people to show you how to use it. There are a lot of states where this is deployed already, so it may already be paid for you to use depending on what state you're in. So you can always send me an email and ask me about what might already be available for you within your state, because it may be sponsored for you already by the DOT. And there's no seat license or usage limit. You're metered to have 3 reports running actively at one time. As soon as we get the new backend built, you'll get a lot more capacity out of it too. So that's all I have. Thank you.
Great. Yeah. Appreciate the opportunity to kind of help close things out. And I think one of the interesting things about our work, as well as what Greg was even kind of talking about, is how we as cities can use data to better inform some of our right-of-way allocation choices or street design choices, kind of moving forward, and how critical it is to have partnerships with the private sector in order to be able to understand and kind of unlock those data flows. So I think there's continues to be kind of a great opportunity to do more of this, and I think that's just one of the things that I would kind of close on for any private sector partners on the call, how technology companies like INRIX and cities and other stakeholders can work together collaboratively. So, we might know exactly where some of our work zones are going to be or where road closures are going to be, and we may have that information in a more timely way. And how can we communicate that out with the ecosystem of users? So I think there's a great opportunity there, and look forward to talking more about that in the future.
Thank you so much, Greg and Jacob. Well, I wanted to thank everybody for joining our webinar today. As a reminder, the webinar has been recorded and you'll receive an email with a link to the recording within 48 hours. Thank you to our presenters as well today. Again, thank you all, and we'll see you next time. Thank you. That concludes today's webinar.